ASP.NET Architect and an ASP Insider, a sister program to the Microsoft MVP family. And today I'm here to talk to you about performance in the JavaScript era. So, we live as developers in some very exciting times in both web development and in the world at large. Of course, being British and being in Europe, I couldn't possibly not mention that we are sadly leaving the European Union. I'm terribly sorry for the 48% of people that did not vote for that. However, SQL Server runs on Linux. 5 years ago, we didn't think that was possible either. Linus Torvalds, when he was interviewed by a computing magazine, when he first released the Linux kernel, said, "What will be Linux's defining success?" And he said, "When Microsoft makes products for Linux, then I have won." And he has. At the same time, Donald Trump, sadly, is still President of the United States, and we might all be thrown into obliteration by a nuke against North Korea at some point. And .NET and ASP.NET are open source. They run on Linux, they run on Mac, they run on Windows. We have cross-compilers for iOS and Android. .NET is now the write once, run everywhere platform that Java once posited itself to be. Of course, we couldn't not mention that Germany are out of the World Cup for the first time in 80 years at the first round. Obviously, certain people must be very happy about this, but it is miraculous nevertheless. And somehow JavaScript has become a popular and widely used server-side programming language. So, what does, oh sorry, that's from my job writing other people's tweets. What does web performance really mean? So, if I were to ask you, all the audience, what is the first thing that comes to mind when you think of web performance? What would you say? Hands up, any suggestions? Nobody?
How fast does the server reply?
Excellent. Server reply time, yes. Any others?
Connection speed.
Connection speed, very relevant, yes. No?
Rendering time.
Rendering time, excellent. So we've got kind of roughly three things. Connection speed, which is the HTTP request itself, how quickly that gets over the wire. Server render, as you mentioned, how quickly an API or a Razor view spits out HTML or data. And lastly, browser load and paint time, how quickly do CSS and JavaScript instructions get executed in a browser. Now, today I'm going to focus on tools that mostly demonstrate point 1 and 2. I will talk a little bit about point 3. However, there are those who are have much more expertise in server rendering and execution, browser rendering and execution techniques. You can look up Leah Verou's blog. She sits on the CSS working group for the W3C. Or you can look up Rachel Andrew, who is an expert at HTML5 and JavaScript APIs. So, how do we measure performance? Obviously, if we're going to improve performance, we need to know what we're measuring to begin with. So we start on the front end, and we're going to be looking at today YSlow using Phantom.js. How many people have heard of YSlow? Very few. One. OK, excellent. We're then also going to be looking at PageSpeed Insights, which is now known as the Lighthouse project. How many people have heard of that? A couple of people? OK, excellent. And lastly, we're going to be looking at Web Page Test, which is an online hosted service. Anybody heard of that? One? OK. And then on the server side, we are going to cover JMeter, made by the Apache Foundation. How many people have heard of that? One. OK. And Mini Profiler and Glimpse. I assume that most people here are ASP.NET developers. You'll probably have heard of one of at least one of these. Yep, a couple of people. Excellent. I will be discussing mostly Mini Profiler today. The reason is because, one, I don't have that much hands-on experience with Glimpse, and two, the Glimpse project does appear to have staled in recent months. I haven't seen support yet for things like .NET Core and .NET Standard in NuGet packages or on GitHub. So I'm not entirely sure how reliable or relevant that may be still today. It may improve, but at the moment, it's not something I'm going to cover today. And lastly, our own custom logging. Now, I'm fairly certain most people here are going to be familiar with things like Log4net and Serilog and how to set up a stopwatch, start and stop. I'm not going to tell you how to write software like that here. So let's get into some demos. Now, this is a lovely little website that I look after called verbier.com. Unfortunately, this site appears to have been compromised slightly earlier today, so I can't show you the live one. What I can do is I can show you what is on my laptop, and I will just go Control-1, that's the wrong one. I just move over here. Now, this site is not responsive. It is not been optimized. There is no compression, there is no minification. This is an example of everything you should not be doing with your websites. Always have one of these in your portfolio kicking around for good demonstrations. Now I am going to show off up here in the browser. Oh, hang on, that's in a private tab. I can't do that. 1 second. Let me just close that, and I'm going to reopen another tab. Let's get rid of that, and that, and that, and that, and that. Here we go. All right, and let's... Perfect, here we go. So now if I zoom in here, YSlow is a tool that was created by somebody on the Yahoo team where around the time that they had developed the UE framework, the Yahoo UI Components framework, which was a competitor to jQuery at the time, is now completely dead and stale. However, one of the tools that they did build out of it was called YSlow. And up here in my top right, I'm just going to zoom in right there, there's a little browser extension, YSlow, and this is available both in Chrome. There's a little hack that gets it into Opera, which is what I'm using today. I believe there are also Safari extensions for it too. And it also comes as a command line utility. All of these tools that I'm going to demonstrate today aren't just ad hoc tools that you can run on a one-off basis. They're all tools that can be demonstrably used in a continuous integration environment. As I mentioned, we need to know how we're measuring, but then obviously we want to track how that measurement improves over time. So, without further ado, let's see what YSlow can actually do for us. So, you get a nice little browser test, and it says run test, and it loads all the individual components and then tells you things that are wrong with it. And then it gives your site a grade out of 100, and this scores a grade C. The reason this one scores a grade C is because I've worked on this one locally, but there are some things that are problematic with it. This page has 21 external JavaScript. You should be compressing and minifying your JavaScript. If you're not doing that, please raise your hand. Don't worry, I won't put you in too much trouble. Anybody not doing minification of CSS and JavaScript? No? Good. Excellent. So yes, compress and minify your images. There's a tip in here about external background images. Has anybody come across the concept of CSS spriting at all? No? Yeah? Couple? Okay, for those that don't know, spriting is the idea that, let's say you do have 10 external background images. What you can do is combine that into one image, therefore it's one request, and then you use background positioning and clipping to only show a small portion of that. As a result, you're only making one image request instead of 10, and you're using CSS to subsequently apply a rule that only shows a portion of that image that you want to show. For example, the menu, the kind of little grey bars in between home and weather, or let's say the tweet icon or the Facebook icon. Those are things that you potentially look at putting into CSS sprites. So let's go down the rest of the list. Use a content delivery network. Now this is generally good practice is you want to move all your static resources onto a separate subdomain. The reason is because if your main domain sets any cookies, login, authentication, session, browser tracking, etc., every single cookie that is set is going to get sent with every single request to the same domain. As a result, each HTTP request is going to be bigger, and as a result, so is each HTTP response, because it's always going to contain that cookie information, even if it's not used, which static resources don't. So what you should be doing is farming your stuff off to blob storage fronted by a CDN. So something like Azure Blob Storage or Amazon S3. One website I worked on in particular was for the Formula E Motorsport Championship. And when I first arrived in their first season, the first thing we did was take 4.5 gig of high-res static photography, because this is a motorsport championship. Their job is to produce high-quality images for press, for fans, desktop wallpapers, press releases, and so on. And we took all of that and we chucked it straight into Amazon S3. And then we put CloudFront over the front of it. Total first month bill, $67 for what was well in excess of 60 or 70 gigs worth of CDN traffic and 4 gigs of blob storage. Amazon gives you up to 5. Azure charges fractions of a euro, of a cent of a euro. I think it's like 0.3 cents per gigabyte stored per month. So 5 gigs works out at what, 1.5 cents, right? Or that's what, 20 cents a year. It's not even a cup of coffee. It's not even a stick of gum at that price. So use a CDN. It will offload, not only will it offload all that processing resource, which shouldn't be done by a dynamic server, shouldn't be done by IIS. You are putting it somewhere cheap, scalable, and affordable. So what else do we have? Expiry headers. Now, as part of the HTTP spec, there is a lovely little header that says expires, and then you can put a date and a time in it. What the browser will do with that is say, OK, I'm going to cache this in local browser for, let's say, half an hour, 24 hours. If you know that's not going to change for a long time, set it for something even ridiculous, like 5 or 10 years in the future. By not setting expiry headers, this is a nice little demonstration. I'm going to quickly open DevTools and move this over. Right, we have developer tools. Right, I'm now going to uncheck, disable, well, I'm going to disable the cache for the first time to show you how many resources get downloaded in here. And let's just quickly reload that. And we've got a count coming up down here. 109 requests, 113, 125. That's quite a lot. Now, some of those are obviously analytics type bits and pieces. Some of those are loaded from different sections. For example, there's a booking.com widget over there. But that's still a lot of resources. It's 152 when it's finished. I'm now going to take off disable cache and preserve the log. So the difference between the next number and this one will tell you how many extra resources are still being downloaded. And we're already at 271. That was on top of 150, so that's 120 images, files, JavaScript, CSS that are still being downloaded. 276 requests, 1.6 meg transferred. So by not specifying an expiry header, the browser does not know that it doesn't need to go and get those resources again. As a result, it's causing unnecessary traffic, unnecessary connections, and unnecessary slowdown. Expiry headers are important. So we now move back to why slow, and what else do we have? Put CSS at the top. There is one style sheet found in the body of the document, which is then delaying paint, because the body has to fully render and parse before CSS rules can be fully applied, because it's loading there. This used to be even worse, because previously someone had taken, you know, the Facebook like button. You know, it comes as a little snippet of code that you copy off Facebook's developer section, and it's a div and a bit of a script, right? And I will just demonstrate, if I look into the source code, somewhere, yes, this little block of code previously had been actually in the header. So if you run this against the production site, which currently is offline, you actually get a worse score. And the reason is a div in the header means that the DOM thinks that the header's ended. As a result, it thinks that all the JavaScript and the CSS, 9 different style sheets, were actually in the body, which subsequently delays render. Again, be careful where you copy and paste your code. Simple error, but subsequently causes performance issues, right? Just from copying and pasting it in the wrong place. All right, back to why slow. Let's see what else this can give us. Reduce DNS lookups. Now, this is fairly good. Components are split over more than 4 domains, so we've got 40 components over there. Now, 1, 2, 3, 4, 5, 6 are separate CDNs for various components. Obviously, we've got Google AdSense, Google Maps, Facebook connects, and those various domains. There's not much we can do about third-party services. Although what is interesting, obviously I'm guessing everyone's been getting up to speed over the last month with GDPR, the joyous thing that your HR and legal departments have been going, we had no idea this was happening, even though it was ready 2 years ago. USA Today, news website in the States, decided to set up a completely GDPR-compliant website. By doing so, they basically removed all their analytics, all their trackers, cookies, everything. Their homepage went from 5 meg to 500 kilobytes, just because different people, different teams within the business had gone, oh, I want this piece of analytics, or I want this piece of analytics, something ever so slightly different without repurposing tooling. So be careful how many third-party components you use, and be careful as to how negatively that can impact people's experience of your site or service. What else do we have? Minified JavaScript and CSS. There are components that can be minified. Now on this, I've actually minified the CSS, but it still scores a grade F. Here's a question. How many people build single-page applications here on a regular basis? OK. Do you do that for mobile, or do you do it for desktop? What type of, is that, are they mobile apps, or are they websites that people interact with? They go to an address? Yeah? OK, how many people here who raised their hand, how many of you are building an app that's basically purely and singly internal for use in the company intranet? Just 1, 2, 3, 4, 5, yeah? That's the only purpose. OK, so for minification, you can kind of get away with it, because if when you're creating a single-page app, obviously you will be lazy loading in certain JavaScript views for things like Angular, React, and so on and so forth. Now, when you know you have a reliable connection, that's fine. What happens when you have a mobile device? The London Underground has Wi-Fi in tube stations these days. What happens if I access this service, and then suddenly I leave the station, suddenly my Wi-Fi breaks, and suddenly that JavaScript view doesn't load, right? That provides a broken and a poor experience, right? And it means that otherwise, what would have been a good user experience and a very fluent user experience across desktop and mobile is now broken just because of lazy loading. So one of the key things I say is, yes, minify your stuff if you are unsure of the network in which you're operating. So if you're working with mobile, tablet, anywhere where the internet could go down at any time, minify and bundle. Because then what you can do is then, as part of your view, you'll obviously request data from an API source. If that fails, fine, show an error message. Say, sorry, we know you're offline right now. Don't let the user discover that your app is actually broken because part of the core functionality, that JavaScript view, can't be loaded because you lazy loaded it. So if you have that 100 meg or 1 gig Ethernet connection in your office and you know you can rely on that, fine. Don't rely on it for your users if you're not in that environment. What else do we have? Configure entity tags. E-tags is an interesting one. An E-tag is supposed to be a hash representation in the HTTP header, basically specifying what the contents are, a bit like an MD5 hash or an SHA-1 hash of the file contents. What it means is that when a server sends back a resource with an E-tag on it, okay, the client can then re-request that resource, same URL, send the E-tag header, and the server will go, okay, is that E-tag the same still? Yes, great, send a 304 not modified. Okay, a 304 means that you can literally truncate the response body, cut down on network traffic, and stop serving, at which point the browser can carry on and move on. If the E-tag is different, the server sends back a 200 and gives you the updated resource. So use E-tags, either that or disable them entirely. As part of this, I will be demonstrating a tool called AZ Copy, which can copy your items up to blob storage en masse very easily. And there are PowerShell APIs that allow you to specify metadata, which will include expiry and E-tags on the resources that you've uploaded. So, and those then get fed through as headers into your CDN and down to your users. So that's Wislow, and that's very nice as a tool. And I will show shortly how to get that into continuous integration. But for now, we'll move on to our next tool, PageSpeed Insights. So we're going to go back to that developer tools section. And there's a nice little section up here called Audits. I'm just going to zoom in on that. There you go. So these are all the different tabs. Now, the Audits one is relatively new. It was added, say, roughly within the last 12 or 18 months or so. Notice the icon Lighthouse, shining light into the darkness of your application. So Lighthouse can perform 5 different types of audit. So we have performance, progressive web app, best practices, accessibility, and SEO. Now, a couple of these are linked. Obviously, performance and best practices kind of tie in quite nicely together. And interestingly, SEO is also tied to performance. Since 2014, Google has been penalizing websites and web apps that don't provide a slick and a fast user experience. So the website I showed you that I was working on, Verbio, that sits at number 9 on Google's page because what's at number 1 and number 2, they've optimized for performance. So they've optimized for mobile, they've got a responsive design. Our site doesn't. So these are linked intrinsically, but we are going to run just a performance audit. And this comes up with some nice statistics as well, telling you why performance is important, including things like Walmart, for every 100 milliseconds they improved page load time, saw a 1% uptick in revenue. Now think how many billions Walmart makes a year. 1% revenue for 100 milliseconds of performance. That's a lot of money. That is a heck of a lot of money. Also, this might take some time because it's both my local machine and the LAN connection sometimes is a bit funny. Come on, Lighthouse. It will get there. Or maybe it's just taking too long to load. Because what Lighthouse will also do, Lighthouse will also test things like intermittent connectivity. It'll actually pretend to throttle your connection down to 384 kilobits a second, 3G speeds. 75% of the world population is still only on 2 or 3G speeds. A great example of this was YouTube launched a light experience, showing lower res thumbnails, removing some of the analytics and tracking behavior cookies and JavaScript that they use to track user experience across the platform. They noticed that the average load time went up, which sounds counterintuitive, right? But turns out the reason is because people who were on 2 and 3G connections previously, they tried loading YouTube and it just timed out. They just couldn't get access to it. So, but now there was a light experience, even though it was slow, they could access it. Suddenly YouTube had a wider audience, which was better able to access that service and those resources because they trimmed it down. That's still taking some time, isn't it? Let's see what we can do about that. Oh, here we go. Wow. Okay. Right. So I'm going to try and maximize this. Right. Again, we get a score out of 100. This scores 0. It's that bad. But it gives you a lot of pointers as to what you can do. Let's have a look. Yes. Estimated input latency. Right, that didn't seem to want to load. Keep the server response times low. 895 milliseconds just to get the server to spit out some HTML. That's far too long, and I will go into some stuff about server render in a little while. Minify JavaScript, save 24 kilobytes and save another 290 milliseconds. Let's have a look. Unused CSS rules, 190 milliseconds and 16 kilobytes. Now that's not much, but there's a magic number that gets thrown around when it comes to user experience, which is 600 milliseconds. And the reason 600 milliseconds is important is because when a user presses something, if they see a response within 600 milliseconds, they think it's instantaneous. Any longer than that, and they perceive it's not quick enough. So 600 milliseconds is our magic number that we really want to get to. Obviously, our 890 is substantially problematic, and I will get into some of the reasons as to why that is in a little while. Enable text compression. So minifying the actual removing white space in CSS, JavaScript, and in your HTML2 can actually improve both paint and response time. What else do we have? Uses inefficient cache policy on static assets, 42 assets found. So I mentioned expiry headers. Lighthouse has already identified 42 of them that should have expiry headers on them. Uses an excessive DOM size. This affects paint time, how many HTML elements are on the page, and how long it takes for that CSS to actually draw all the separate rules. 3,738 nodes. That is a lot. JavaScript boot up time is too high, 8,750 milliseconds. So even after we've got our CSS and our JavaScript and our images loaded, it's still taking another over 8.5 seconds just to execute JavaScript. That's painful. And part of the reason is because the person who built this didn't just include jQuery, they included MooTools as well. Anybody remember that one? Yeah? Right. 2 UI frameworks. Why? Why would you do that? I told you this is a perfect example of how not to do things. I wasn't kidding. So there is a lot in there. Now, again, Lighthouse can be run as a command line utility. It outputs either an HTML report or a CSV file or a JSON file. And again, I will demonstrate how to do that in a continuous integration environment accordingly. So we've now looked at Lighthouse. And finally, we will look at web page test for the client side. And let's take a look. Now I'm going to run this against a different site. Let's just pull you open. webpagetest.org. So this is a publicly hosted service. This gives you tons of options in terms of what you want to test and also location where from. This gives you a perfect holistic tool to look at the performance of your site, not just from where you are. Let's say your server's in a UK cloud and you're in the UK. This gives you a chance to actually test network latency performance issues from across the globe. The default option is from Dulles in Virginia, which will test desktop, browsers, Android, and iOS. So it will give you a full kind of view as to how your site's performing on different devices. But you can also choose specifically just to test for iPhone, iPad, Android, and there's lots of options further down. Country list, South America, Europe. Here we go, Amsterdam, with a number of companies there, and across Africa, Middle East, and Asia. So we are going to stick with the default option, and we're going to test the website that I worked on 3 years ago, FIAFormulaE.com. So and all this gets run in virtual machines that people run their own nodes and can basically contribute back to this. It's also an open source project on GitHub. So once it's started, it will then run through the same kind of things that the network tab in Chrome will do. It will show you a breakdown of all those resources, how long each one takes, and then it will also give you an indication of paint speed as well, like Lighthouse will do. But there is one tool in here which I think is the one that works best, and it's one that you probably don't think of. But how many people in this room have a mobile phone contract that has an unlimited data allowance? Anybody? Just me then? There we go. So people will have what, 10 gig, 20 gig, 5 gig, something like that on your mobile phone? 20? Right. So, but you'll be capped, okay? So there's a nice little button up here, cost. How much does it cost to access this website? Cost in US dollars, both on postpaid, monthly contracts, and prepaid. So it's an ancillary service called whatdoesmysitecost.com. So accessing the Formula E homepage from Canada on a contract costs 77 cents. Now that's just on the first load, okay? Because it's big, it's heavy, 6.27 meg. I guarantee you every single request after that will be a lot lower because they're using a CDN, because I set it up for them. But that's still pricey. Think about this. You have an Amazon app, right? You go to the homepage. You go search for a product. That's 2 page views. You go look at a product, 3 page views. Add to basket, 4. Back to homepage, 5. Search again, 6. Find a product, 7. Add to basket, 8. Shipping, billing, card details, thank you, 12 pages. If it was that bad on Amazon, that suddenly placing your Amazon order has just cost what? $8, $9 in Canada? That's expensive. That's an overhead to your users. Our job as part of performance, I mentioned there's obviously the perception of speed, but there's also a cost. There's a hidden cost, one that you as developers do not directly see, but one that you absolutely have to take into consideration. So please think about these minification techniques, reducing the requests, are all for this kind of purpose. You want to make sure as many people can access your site and as widely as possible. So at the lowest cost to them. Otherwise, you are doing them a disservice. So now that we've covered all the front-end tools, we now move on to some more interesting stuff, such as JMeter. Now, JMeter is a tool created by the Apache Foundation. As a result, it has the misfortune of being written in Java. But it is extremely flexible in what it can do. Now, at this point, I'm going to switch to duplicating the screen, because this does not work trying to control this and demonstrate it. Where are you? Go on. There we go. So, all right, so we take a look at JMeter, and this does not look like much at the moment, so, but it gives you the option for a test plan, and then we can create something called a thread group. So, number of threads, number of users that we want to pretend to be, ramp up period. Let's say I want to run a test that tests, say, 5 minutes worth of traffic increasing, starting from 0 up to however many, and a loop count. So I'm going to say 200 users over 30 seconds, loop 50 times. So that means 10,000 requests are now going to be sent to somewhere. The question is where? And we have here samplers. Now this shows you the real power behind JMeter. This entire list is every single type of request that JMeter can make. So we're going to focus on HTTP requests, but if your network admins wanted to test the resilience of your FTP service, they could. If you wanted to test the resilience of your database connectivity, there's a JDBC request. If you wanted to test Active Directory integrations, there's LDAP. And if you really want to hack off your network admins, you can send raw TCP data right down at the bottom. We're going to focus today solely on HTTP request and what we can do with that. And the keyboard never seems to want to work inside a Java window. Here we go. So we specify a protocol, an address. Interestingly, we can specify a method, and if I zoom in on that again, it will support a full range of methods: get, post, head, put, options, trace, delete. You can use this not just testing the resilience of, say, getting a front-end website. You can use it to test API calls. So you could actually load in, there are more options where you can actually load in data from CSV or XML files and do thousands and thousands of submissions to an API endpoint to test that it's resilient under strain. So there's a huge amount of flexibility in this tool, more than I can cover in a single hour's talk, so I won't. And there is plenty of documentation online at the Apache Foundation website too. But we will actually run a test and then show what it can do. And we want... One of the things I do like doing, actually, is I have a script kicking around, which I may make available on GitHub. Everybody is familiar here with a sitemap.xml file. It's a list of the URLs that you submit to search engines. And if you're running a CMS type thing, you would keep that regularly updated, and the search engine would crawl your sitemap and then crawl the links inside the sitemap. What I like doing is I like actually loading the sitemap in here and then testing every single URL inside it, because then that will give me an idea which areas of the site, because the home page might be blisteringly fast, but there might be something slightly lower down, maybe a streaming page section or a shopping section, a product category section, whatever that may be. That may be running slower than average. And you want to be able to diagnose that and spot it so that you can then delve into it in a little more detail. So we are going to test today the FIA Formula E website. Now, I do not recommend, the whole point of the graphic tool for JMeter is to be able to construct these tests, and then that tree structure gets saved as an XML manifest. It's called a JMX file. What you would then ideally do, as part, and most build servers do support this, is actually throwing that JMX file to a command line JMeter, because it runs as a batch script. And you throw the JMX file into that, and then you can actually run slaves. So you can run a whole TCP-controlled master-slave situation. So if you want to run this test, which is 200 users and 50 operations per user, so 10,000 requests in total. If I want to run 100,000, great, I can set up slave machines in a master-slave coordination and get each one sent the JMX file and collect those results up all. Suddenly, I've tested not for 10,000 requests, but 100,000. And what's interesting is that JMeter slave configurations are available in both the Azure marketplace and the AWS marketplace. So you can literally rent a slave by the minute, run your test, shut it down, pay pennies, basically, for running an enormous performance test. If you want to run something massively at scale, say 50,000, 100, 500,000 requests, you can do that using JMeter. It's a very powerful and very flexible tool. So, and lastly, we're going to add something that actually shows us what we get in results, which is a graph. So, and of course, the graph results can then be saved to a file, which again can then be picked up by continuous integration. So, off we go. Let's see what this actually does. Let's have a look. And play, and no, I do not want to save the test plan. You'll notice in the top right, it's starting to count up that little thread group. So 24 out of 200, we're now up to 50. And we're starting to get some results coming through. So we have an average server response time, 1600, a median, which is the pure middle value between the lowest and the highest. So, and we have a rough throughput as well. That generally, I suspect, is more capped by the Wi-Fi than anything else. But yes, this gives you an average kind of response time and gives you an idea of how a site will handle load times under stress. So, and we've collected so far nearly 2,000 samples, so that's about 20% of the way through the test. So we'll stop that briefly. But that gives you an idea, certainly looking at the HTTP request options, that gives you an idea of what you can test from HTTP stuff from the web level all the way down to the actual TCP socket level. This tool is amazingly powerful, and it's free, and it's available from the Apache Foundation's website. And when that decides to finish, it's fine. This bit takes ages. For some reason, I always get a lock, so bye-bye command window. Right, and display settings. All right, and lastly, I'm then going to show off Mini Profiler. So how many people have heard of Mini Profiler? Couple of people, okay, excellent. So Mini Profiler was built by the Stack Exchange team, so the guys that make Stack Overflow. It's a phenomenally brilliant kind of diagnostics hands-on tool. This is not something that's necessarily automated. This is something, once you've used JMeter to identify certain problems with server response, this is where you drill into the detail and actually start inspecting what your MVC views in this particular instance will come back with. So we will go to the Verbier website again, and up in this top corner, there is a nice little set of divs with lots and lots of millisecond counters. This is Mini Profiler, okay? So there are plugins for Entity Framework 5 and 6. There's plugins for RavenDB. There's plugins for MVC. There's plugins for virtually everything within the kind of major Microsoft ecosystem that you deal with. So this site runs on Umbraco, so it's got Mini Profiler built in, but it's very straightforward to add to your projects. I highly, highly recommend it. And I'll demonstrate why. This is what you get. A full breakdown, CSHTML by CSHTML, of how long each render is taking. We have one there in particular taking 450 milliseconds. I mentioned that magic 600 number. That's taking up 3/4 of that already. And this is running on my machine. This is a 32 gig RAM, i7, SSD, right? So this is fast. That is clearly not. So this also gives you indications of where there are duplicate queries. Now, because this is a CMS, there will be duplicate queries, but we can see exactly what those queries are in full detail and exactly how long each one took. Now, because these are repeatable and SQL Server is smart enough and has cached them, 0.5 milliseconds, I'm not worried about that. But this can give you an insight into your own custom-built stuff as to how long these queries are taking, where there might be problems. So it's a phenomenal insight into the page that you're looking at. And what's great in particular is if I just bomb out of that and reload, you may have noticed that was the bottom one. Previously, there were other items ahead of it when it loads. So these are all the background tasks that have been running as well. So there's a 30-second scheduled task that happens, and I can even examine that. This will keep an eye on everything that has executed since the last time Mini Profiler showed it to you, basically. So it's a kind of rolling active log of what's happening, both what you can see and what's happening behind the scenes. So, and in fact, if we go there, that's taken even longer. That is hugely problematic. Oh, look, there's another script that's now taking 487 milliseconds. This is problematic. So, all right. So now we've discussed the tools. How do we measure? What are we measuring? And now we want to know, how do we improve it? So, and I will warn you, this list is extremely long. Oh, hang on. I just realized wrong screen. From current slide. Try that again. There we go. Right. This list is long. It's longer than the list of Robert Mueller's current subpoenas. It's also longer than the list of women that Donald Trump has sexually harassed. Not longer than that, though. So we talked about the HTTP request level. Make your requests as small as possible. Cookie-free domains. Move your assets through to different domains where cookies aren't needed. Move your stuff to blob and CDN. It's cheaper than a coffee. Gzip and deflate static resources. Now, gzip and deflate are both compression mechanisms that are supported in every major browser, okay? You should be gzipping and deflating except for dynamic content. Static content, no problem. Dynamic content comes with a security vulnerability called crime and breach, where basically the compression algorithm can be used to break apart an SSL3 connection. As a result, if you are serving user authentication tokens, session cookies, anything like that that could be used to compromise a user's session, don't gzip or deflate. So, or if you do it inside an environment that's protected. So, for example, some people said they were developing enterprise internal-only apps. For that kind of stuff, you could probably get away with it because you're fairly certain that your users aren't going to be smart enough to know how to run that kind of attack, right? If it's public-facing, though, don't do it. Static resources, fine, yes. Dynamic resources, it's a no-go. Caching on static resources. I've talked headers. We've talked the expiry header. Set your expiry headers. This is a one-line thing in your web config, or it's a one-time property using PowerShell when you change something on blob storage. E-tags, same principle. E-tags on dynamic resources are a lot more difficult to do because you actually have to work out the response body and then send an E-tag. That's potentially more performance cost in terms of CPU resource than you're going to get out of actually the network traffic. So I generally recommend don't use those on dynamic resources. The cache control header is one that I haven't discussed because there are private and public. There's a lot of different configuration options which could potentially be misinterpreted or misused by other routing or proxy devices between you and the client. So I've heard stories where people say they've tried accessing updated websites outside a network, but they can't see it because something inside a proxy has misread a cache control header, and therefore it still thinks that it should be caching a resource when in actual fact it shouldn't. So cache control, use at your own risk. I don't fully understand the detail of the cache control header from the HTTP spec, and I don't think it's necessarily implemented rigorously enough for you to warrant using it. I think you can get away just fine with the other two. So, reducing asset size. Minify your CSS and JavaScript. Like I say, unless you know you're working on a 1 gig enterprise Ethernet connection in an office, you don't know that lazy loading is going to be reliable. So, minify and compress and deliver everything in as few requests as you can. Use an in-memory cache to boost speed. Now, one of the sites I did work on, aside from Formula E, was this one, which is universalmusic.co.jp. So, this website covers 26 different record labels in the Japanese market, 2,500 artist representations, including the likes of Lady Gaga and Justin Bieber, all the way down to your local J-pop and K-pop bands. So, oh, look at that. There we go. Brief network interruption. So, I was responsible for upgrading some of the functionality of this site. One of the interesting things is that this has got over 164,000 separate pieces of content within it. That's a hell of a lot. And one of the main issues is that on the homepage, there is a news section. This news section has to populate at least 5,500 news items from across the site, order them all by date, and then show the top 3. That is a very big and a very expensive query. So as a result, instead of running it there in the view as you see it, what we did is we ran it at application startup. We'd run the query, gather all this data, shovel it all up into JSON format, dump it into RavenDB. Querying that was faster. So we did. We used a file-based JSON cache in RavenDB to subsequently store that data, and then we had a pub sub mechanism. Any new news items would end up going to RavenDB because it was faster to query from there. So if you know how to use these tools, do. There's Memcache, there's Redis, there's Raven, there's Mongo. Well, if you like Mongo, I don't, but there are plenty of fast tools that are designed kind of NoSQL type data stores. That's what those are designed for, right? When you're dealing with problems like that kind of scale, use them. So, don't be afraid to use those. Oh, one thing I will say, a caveat, if you use something like Varnish as a reverse proxy, you can stick Varnish in front of your web service and it will cache HTML responses. The Formula E website did use Varnish during their first race, but it was misconfigured, and so it started leaking data that had been posted to the server. Usernames, passwords, no credit cards, but somebody got fired, I got his job, and they paid a £25,000 fine. And that was a minor breach during one race. So, caveat emptor, if you're using reverse proxies or any kind of caching layers in front of your site rather than behind it, be very careful you're configuring them correctly, otherwise that could be a very, very costly mistake for your business and your career. So, but we now move back to other things. And send 304 where possible. I mentioned e-tags. If you know that the resource hasn't changed, cut the response, send a 304. Your network traffic will thank you for it. And in terms of server render, I've already covered use of JMeter for profiling. I'm going to cover mini profiling now, and I'm going to cover why you should never use the word dynamic in your dynamic as opposed to var or as opposed to a type. Dynamic is based on a class called dynamic object, which is in the system.core namespace. Basically, if you're implementing it with something like JSON, it's fantastic because it allows you to do dictionary level lookups on properties that you aren't necessarily sure exist at the time. Think about something like the Facebook API that changes on a weekly basis, or used to anyway. Dynamics can be great to handle data structures where you don't know the contract up in advance. However, to do that, it basically does a giant try-catch block. So there are a number of methods implemented, which will be try-get-member, try-get-field, try-get-method, etc., 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 because it doesn't know when it's accessing that. It doesn't know whether it's a property or a field or a method or something else. As a result, you end up with something like a 20-layer deep try-catch, try-catch. Here's the thing. Every time you hit a catch, right, an exception is generated. Even if there's no exception variable being declared, an exception is still generated by the runtime. And we all know exceptions are very memory heavy, right? This is why you shouldn't use Dynamics. The Formula E homepage, when I first pulled it out, well, when I first downloaded it, they didn't have source control at the time. Yeah, it was that bad. When I pulled it down and I enabled Mini Profiler, the homepage render was 4,200 milliseconds. Mini Profiler told me that was one Razor file, just one. It was a homepage carousel that loaded 5 images. And because it was using Dynamics, it on its own took 3,500 milliseconds just to render one block of HTML. By the time we'd finished removing Dynamics from every single section of the website where we could find it, that homepage, the entire of it, came down at 146 milliseconds. 97% improvement, just because we use static typing instead of Dynamics. So when I say don't use Dynamics unless you're working with JSON, I mean it. I will come, I will visit your office, I will hunt you down, and I will sit there and rewrite all of that code with you. But don't use Dynamics. And that is going to go on my tombstone. So, now the next question, obviously, once we've talked about how to measure it, how to improve it, all the various tips and techniques that we can use, how do we subsequently monitor? Because after all, we want resilient, strong, and stable websites. So, we keep at it. We use application monitoring. There are a number of different tools that we can do to keep measuring and to keep improving. Every time we deploy something, we need to know whether the speed has gone up or gone down. And we use all of these tools collectively to find out why. New Relic APM, application monitoring. It's an amazing tool. We installed it on a custom application at Universal Music Studios, which was using SignalR, AngularJS, and Web API. And there was one particular page which was proving particularly problematic. And New Relic gives you all the information about the actual cost of the network traffic, how big it is, how long it took to handle, and then how long it took in the .NET runtime to then spit out a response. It's brilliant. However, on this one URL, it was saying it was taking 3,500 seconds. Really not very cool, given it's just a JSON API call. So I was wondering, is it the dependency injection container? Is it Unity? Apparently Unity is quite memory heavy sometimes. So I went through, started looking, and then I jumped into the JavaScript side, and I realized that what was happening, when a request was being made using SignalR, there was then a JavaScript callback that was being run, and then the connection was being closed. Now, obviously, this would make the connection persist and stay open. This being SignalR, you can do that. I swapped the 2 lines over. So we closed the connection and then ran the callback. Server response time dropped to 200 milliseconds. It wasn't a server problem. It was a client-side paint problem within the browser, within Angular, at which point I threw it to my front-end developer to fix. So it suddenly stopped being a .NET problem because Mini Profiler helped me identify that it wasn't a .NET problem. A Gibraltar soft loop. How many people have the terrible misfortune of having to work with WinForms or WPF today? Anybody? No? Wow. All web developers. Fantastic. So Gibraltar soft loop is based on a framework called PostSharp, which is an aspect-oriented programming framework for environments that don't have AOP enabled. So MVC is an aspect-oriented programming paradigm because you can have attributes that can then change what happens to the response of your function call, right? That's what AOP is kind of really for. And Gibraltar Soft builds on PostSharp's interweaving IL capabilities to allow you to add attributes to methods to then supply logging up into the cloud. Fantastic tool. They've got desktop, mobile, and web clients. And the guy who makes it, the guy who makes PostSharp, Gail, is a genius. If you ever get to hang out with him in Prague, take a notepad, you'll learn a lot. Smartest guy I've ever met. And Gibraltar Soft is run by a personal friend of mine called Kendall out of Baltimore. So, and lastly, we've got Azure Application Insights. You go File, New, Web Application Project. There's even a tick box for it in Visual Studio. It's free, it's cheap, it gives you some basic reporting. I think you can pay for some higher end features, which I've never really looked at because I prefer New Relic. But again, these tools are all either free or ridiculously cheap to implement and give you ongoing monitoring performance for your applications. And then for front-end performance, obviously, I talked about how some of these tools can be used in continuous integration. YSlow allows you to output your results of that score out of 100 into a JUnit compatible XML file. This can then be picked up by TeamCity and Jenkins or any other compatible system. PageSpeed Insights, Lighthouse. Now, I'm currently working on a patch to try and get that to output in JUnit format again. because that needs to obviously be quite useful and important in a CI environment. And lastly, of course, JMeter with the concepts of command line running master-slave environments. So all three of those tools can all be used in harmony to subsequently measure front-end and server-side performance in a CI environment. So, and the last thing I will show off, I've been promising I would get this onto, onto GitHub soon, but I've still yet to get the thing finalized and working. So this is a Docker image, which uses the OpenJDK Windows Server Core 2016 runtime, and it downloads and installs Jenkins, and then it goes through a few other bits and pieces. Where are you there? Then we install .NET and ASP.NET, MS Build, NuGet, and then let's scroll that down a bit further. Once we've got NuGet there, we then install Git, JetBrains static code analysis tools. There's some command line stuff that will do memory profiling for you. That's pretty neat. So you get that in there for free as well. You then get NUnit, and then we get a few others, which are, let's have a look. We've got then XUnit as well, should you want to use XUnit instead of NUnit. We've then got JMeter, YSlow, and AZCopy, which I mentioned earlier, which is, excuse me, it's a command line utility for basically being able to send a bunch of images, files, CSS, and JavaScript straight up into blob storage with a given key, basically. So you can immediately farm your stuff off for pennies a month and immediately go, right, I don't have to worry about serving those up or the performance implication of doing so. So lastly, it's got some extra bits and pieces on the bottom, which I'm hoping to get sorted. Has anybody come across some chocolatey before? One, two, couple of people. Okay, so for those that haven't, chocolatey is a fantastic, it's basically a NuGet package manager, but for desktop installables. So exes, MSIs, all that kind of stuff. It's also got dependency chaining. So if I need to install JMeter requires Java, which requires JRE, so it does all of that stuff, which is brilliant. And it can handle upgrading all that stuff too as new versions come out. So we then go install Phantom.js. So Phantom.js is a headless browser where you can then run YSlow inside it. So this is how you run it as a command line utility using a headless browser. And in this case, it's Phantom.js. We then install Yarn. And the reason is because Lighthouse actually comes as a Yarn module, and you have to be able to throw configuration into it to be able to say, I want to run a performance test or an SEO test and so on. And that's all done as a Yarn package. So Yarn is, I think it's Facebook's basically an NPM compatible package manager, but they say it's better because apparently nothing is better than going, oh, that open source project doesn't quite what we do, we'll make our own. Yeah, because that's what open source was really for. No. Right, so then I'm going to be putting a Lighthouse configuration on Gist to be able to demonstrate this stuff at some point. Then we've got an NPM module for web page test, and then we run some extra stuff, which then sets up and configures and installs all the Jenkins plugins that you're going to need. So this ideally will turn into a fully fledged version of a Jenkins server with all of those command line tools ready for you to run. So when this is finished and when it does end up on GitHub, and I will post the link inside the meetup comments after when it's ready, which fingers crossed will be soon. I've been saying that for a while though. So, but then it stores all the plugins, and then you can basically feed in a web application project, get it deployed, and start running automated performance tests against what you have as a kind of out of the box, here's 5 minutes, and off it goes. So, and I promise, when it's finished, you'll be definitely some of the first to hear about it, as all the previous meetups have as well. So, but yeah, that hopefully gives you some idea of what you can run at the command line basis. And in fact, if I just show off, here we go. So if I wanted to run some tests, I would run just literally Phantom.js, and then I throw in the yslow.js file, which is a plugin that comes down from GitHub. And then you just throw in the local address and then -f JUnit. Lighthouse, you throw the URL in and then go /output. The entire Lighthouse and web page test modules, they're all documented on NPM. So if you simply go to, in fact, I'll just demonstrate this one, yes, .com. Lighthouse. Is that right? That work? Is that it? npm.js, that'd be why. Right. And package Lighthouse. Here we go. So this is the command line reference for Lighthouse. When it gets there. So obviously, I've demonstrated using Lighthouse within Chrome DevTools, but this is how you would then, these are the CLI options, which are long and extensive about the different types of reports you want to run, whether it's an SEO report, whether it's a performance report, whether it's an accessibility report. All that stuff can all be configured through the command line like that. It's all documented. And lastly, the same applies for web page test. Now, web page test only will test publicly facing websites. Obviously, it can't access stuff that's just hosted on your internal network. There is another Node module that covers that, which I've forgotten. It's a tunnel of some kind. So, but again, all the options are documented. Locations around the world you want to test it from, devices, Android, iOS, desktop. There's far more in here than I can talk about in a single hour. But there is plenty for you to go and explore and discover, you know, for your own projects. And lastly, if you do want to test stuff internally, there is, if I'm not mistaken, really? Just on time. Come on, let's get that loaded. OK, that's refusing to work, so let's go back here and try this one. There is a search, and there is a tunnel package. Oh, no, it would appear my internet's completely gone, so I'm afraid that'll have to wait for another day. Other than that, folks, I'm willing to take some questions, but thank you very much for listening. And there is my GitHub and my Twitter profile, should you wish to follow my inane ramblings about tech and politics. Any questions? Oh, yeah. Microphone's coming to you.
Here you go.
Yes.
Yeah, I was wondering, HTTP 2, you didn't mention that. And
I was going to, yes. Now, this demo occasionally works. Depends on the Wi-Fi. It depends on the connectivity. HTTP 2 is the new spec which covers multicasting, basically, for HTTP connections. So instead of having to minify your CSS and JavaScript files, reason being is that normally you'd want to minify the number of connections, right? However, HTTP 2 allows you to reuse connections. So in theory, you can download multiple files over a single persistent connection. However, if you're a .NET developer, serving stuff over HTTP 2 comes with literally two clauses. One, you have to be running Server 2016 or Windows 10. If you're on an earlier environment, you are quite simply out of luck. HTTP 2 is not built into any earlier platform than Server 2016 or Windows 10. Secondly, you must be serving over TLS 1.2. Now, obviously, we know that Let's Encrypt is a good thing and we can get 3-month certificates, but if you're still serving stuff over unencrypted HTTP, and I'll let Troy Hunt explain exactly why you're wrong for doing that, but if you are still doing that, again, you are out of luck. Okay, on Windows support. Now, NodeJS support does have it on Linux devices, right? Because HTTP 2 support is built into the underlying Linux subsystem. But it's brand new. It's only been ratified 3 months ago. It's only just made it onto Windows Server and desktop platforms. You can't necessarily rely on it being there. I will show off the demo, though. Akamai have got a demo on it, which is, where are you? There we go. Now, right, and my internet's gone. 1 second. Yeah, that's very odd.
Try this.
Brilliant. Thanks. Yeah, your guess now is this bit. Oh, it's extra bonus challenge. I'll buy anybody a drink that can type "the quick brown fox jumps over the lazy dog" in my laptop because it's a non-QWERTY layout. So extra bonus, you get a drink if you can do it. This could take a while. Okay, check. Hang on.
No, please don't do it.
Yeah?
Yeah,
It's not touchscreen.
oh.
Yeah, I wish it was. Excellent. Let's try that. Okay. Yeah, the guest Wi-Fi seems to have disappeared. Right, okay, let's get back. There we go, and refresh. Okay, so this is Akamai's demo of HTTP 2. You may find, actually, the HTTP 2 on the right actually takes longer than the one on the left, depending on how good the Wi-Fi is today.